Hey guys, the last assignment that we had post lab and the experiment was a little bit confusing. So I just wanted to go over like what you guys need to do for this post lab and how to conduct the experiment actually. And so let's get started. Your first question in the post lab is list the members of your lab group, and it's just 1 point. So it's not really important, but you just put your name basically and then say that it's an individually done, or you don't even need to put that, you just put your name. All right, but the second part of the post lab is 70 points worth. And if you look at it, it says please submit your worksheet, data, and calculations from the lab. So where are those numbers coming from? How do you get that 70 points? So if you actually go to your experiment, like actual experiment paper, which starts with this experiment 1. So normally this is designed for in class, and we are, yes, having online version, but some classes or some schools are actually going to school, so they are basically face to face. So some schools are going to do this in the class, so that's why they need to include everything in this lab portion. So that's why we're going to be skipping some of them, and don't just look at it, why do they have motion sensors? Because some schools are actually following this. Alright, so this is why they are having those options. So I recommend you guys to read the background part, and then in the procedure they tell you what to do. But again, since we are not going to be doing the experiment directly, or we can do it directly, but you're going to do it at home, but you don't have to. So that's why part 1 is basically for the ones who is doing the experiment in classroom with the materials that are provided. Since we are not going to have that part, then we can skip part 1, and if you look at it, there is no point for part 1, so you just skip part 1. And in part 2, constant acceleration, you'll be exploring the constant acceleration model accurately describe the motion of a falling object. I'm going to talk about the physics of this a little bit, but now let's go over what else you guys have in this paper. And then they tell you what to do, follow that, the instruction. But again, since we are not going to do it, you don't need to know how it's working out, but you guys need to basically have an idea how they do the experiment. So in here, they tell you the assessment. So this section summarizes information regarding the assessment of post lab 1. So the worksheet for this lab should be scanned, photographed, and uploaded. So in question 2, you're going to be able to actually upload the file. So that is basically what we're talking about. All right, so page 5. Your page 5 looks a little bit different than this one, but I just edited this version, so I'm going to be sharing that with you, so you're going to be able to write on this. So page 5, normally it didn't seem like a question to me, so I do apologize for not like putting a writing portion for this section. So normally they have the question and they have the rubric underneath. So I just deleted the rubric, but you have access to the rubric in the previous, like on Wednesday's file. So, but I'm going to put that the new version where you can actually write your answer to experiment setup and procedure. So as you can see, this is 20 points. And then the result is 20 points, so that is making 40 points. I'm just trying to explain that 70 points to you, and I'm going to come back. So part 1, not graded, so just skip it. Part 2, as you can see, this is another 10 points, so 20, 20, 10, and this is 50. And if you want to use the tabulated data, you don't need to copy paste anything. I basically copied and pasted for you, so if you want to use the tabulated data, you will be able to use that. And I'm going to go over the option one more time, but this is the version where you are using the tabulated data. And 20 points is going to be another like points for this paper, so that 70 is basically coming from here. That 20 points, another 10, 30. You skip part 1, 20 points, 50, 20 points, 70. So that means you guys need to submit your page 5. You skip page 6 because there's nothing graded in this part. And then page 7, there's 10 points and your data. And then page 8. So you need to submit 8, 7, and 5. And well, you can just skip this, and then you can actually upload the entire packet. There's no problem with it because you have one option, like one file to upload. So you can just like upload the entire thing. Or if you are not feeling comfortable working on a computer, you can write everything on a paper and then take the picture of what you write on the paper, and then you can just upload that as a whole. Alright, so this is where the 70 on the post lab coming from. So which means like 70% of your post lab is going to be from your experiment actually. So what are your options? So since we are not in classroom and we are not using the lab materials, you basically have 3 options to do the experiment. So they shared those 5 videos to you. Which paper is this? This is Lab 1 experiment data. So if you look at this experiment data paper, you're going to see 5 videos. Once you click on it, it's going to basically download the video to your computer. And here are 5 videos. And let me play those for you. They're pretty short videos. And as you can see, a guy is basically dropping a bouncing ball from certain height. And in the background, you have white background. And then you see they are trying the same thing 5 times. So, and then they basically have measurements for 5 times. Alright, so basically you are going to be analyzing those 5 videos. This is your option 1. Get the videos and then use this link. You see, this is video analysis program. So once you click on it, then you guys are going to come over here, and then you guys are going to select a video. And then, to be honest, I didn't like dive into this and then learn how to use this, but if you actually play around with it, you can actually get your data points. But I didn't find this user friendly. That's why I wasn't able to like dive too much into details. So I don't know how that works 100%, but you don't need to worry about it because this is option 1. Get those watch the videos and then you do your own video analysis. Your second option is go to the tabulated data and use those numbers as it is. So you don't need to do the experiment or you don't need to do the video analysis. So if you're choosing to go with the tabulated data, and this is going to be the option for you, and as you can see in your experiment paper, I have already copied and pasted those. So there is no point difference in between using the tabulated data or getting your own data points. So it's all up to you, but I highly recommend using those tabulated data points because they are more accurate. Alright, so that's basically what it is in the experiment part, like how those points distributed and what you're supposed to do. If you are using the tabulated data, then how do we answer the question? So this question on 5, experiment setup and procedure. So you didn't do the experiment, then how am I going to explain the procedure? Well, you are going to basically look at the video that they have posted in this lab data, look at the videos, and then explain the procedure. But you need to indicate that you are using the setup in the video that is shared with you. Alright? So it's important that you are stating that you're using their video. So that's what you're going to do. And then clearly and concisely summarize the design. You basically explain the picture, like the video, setup, and the steps you followed to performing your experiment. So don't think like too advanced. You basically pick a ball and then click or decide a certain height, make sure the behind is clear, and then drop the object, and you take the video from certain angle or from right in front of it, and then that's basically your how you perform the experiment. All right, don't think like too advanced, it's simple. And then the results. So include graph or tables to summarize important message from our data and explain what physical properties are represented. For example, if you're drawing attention to the constant coefficient that relates two variables, include a graph of the variables that's shown, the slope, and then explain what the variables and the slope represent. Clearly organize and label any tables or graphs. All right, so this is what I'm going to talk about. This is the physics part of it. So now let's think about what's going on in the experiment. So you are dropping an object. An object is going to basically free fall, because remember the definition of free fall, anything that is falling under the effect of gravity only. So once you drop the object, it basically only force acting on it, gravity. So it is going to accelerate with the gravitational acceleration. And what was the gravitational acceleration? Theoretically, it is 9.8, right? So then you expect the object to speed up or accelerate with 9.8. What is the meaning of speeding up with or accelerating with 9.8? That means you are going to gain 9.8 meters per second every second. But once we look at the data points, we are not measuring velocity and time, but we are measuring position and time. So then how can we go from position time data to acceleration time data? All right, now let's look at the physics part of it. So if you remember the first equation, it is delta x v initial time plus 1/2 a t squared, right? So over here, a is your acceleration, delta x is your position. So as you can see, you have those two variables in the same equation. So that means there is a certain relationship in between those two variables. But we actually have another variable over here, which is initial initial velocity. Give me a second. There you go. So that initial velocity is going to be basically make it difficult, because velocity is also a variable. But once we think about it, we actually have zero initial velocity, because we basically dropped the ball from rest. So my initial velocity is 0. Then I have a nicer relationship, because I have basically three variables: position, acceleration, and time. And this is just a number, and it's not really important. All right. So then what will be the actual relationship in between acceleration and position? If you play around with the I think I should just not have that. All right, if you play around with the equation, take this 2 to the other side, and then divide both sides by t squared, then you basically find this final nice equation. Acceleration is 2 times delta x over t squared. So why do I say this is a nice? Because now I have delta x over t squared, and this is going to be related with acceleration. So what does that mean? The ratio of delta x to t squared. And when you multiply that ratio with 2, you actually get the acceleration of the system. And what do we have? What data do we have? We basically have delta x, we basically have delta x to time data. But what do I need? Because this is the relationship, delta x and t squared. So that means if I actually get the t, like square of the time values, then I should have a certain ratio, delta x to t squared. And I think I need to talk about math over here a little bit more. So in math, so you always see those, but you probably don't like pay attention too much or don't really understand the meaning of those. So in math, if you have a variable a and if you have a variable b, a to b ratio must be linear, okay? And a can be anything, b can be anything, but a to b, if you are sketching a to b graph, that must be linear. And it doesn't have to be increasing, it can also be decreasing, but it must be linear. That is basically the rule of ratio. One increases, the other increases. One decreases, the other decreases. And this is basically a to b ratio. And then you might be asking, then how do we have curve? Then let's say x to y square. Then, and if you're making x to y, whoops, come on, x to y graph, then you do not expect this to be linear because x is proportional with the y square. Alright, so then you are going to have something like this, or the other way. I didn't actually think about like how it should look like. But you see, x and y square are related. But if you're making x to y, then you are not going to have a linear graph. But is there a way that you can get a linear graph? Definitely. If you actually look at x to y square ratio, you must get a linear graph. Alright, that's how it works out. Alright, and so that's why I actually put over here a can be x squared and b might be 5y plus 3x. It doesn't matter what they are, but if you are drawing the x squared to 5y 3x, and if the relationship in between those two variables or those two scenarios is like this, then I can say that this is my a and I can say that this is my b, and if I sketch a to b graph, I must have a linear graph. Alright, so what is the importance of linear graph? Slope. So what is slope? Slope is basically the ratio of, I hope that I'm gonna have, there you go. So once you have a to b ratio, so slope is basically going to give you what? Slope is going to give you delta a over delta b, meaning change in a divided by change in b. And if the relation a to b is linear, then you will know by looking at the slope, you will know the ratio of a to b. Alright, and again, if this is linear, then this is just a constant number. Then, if we revisit our physics portion, this model tells me that a is equal to 2 times of delta x over t squared. So what does that mean? If I can get delta x to t squared, then I should expect a linear graph. And when I get this linear graph and get the slope of this guy, what is going to be the slope of this graph? This guy. The entire thing. You don't need to know delta x. You don't need to know the t squared individually. If you get the graph of this guy and get the slope of this guy, then you are going to actually have the number for this delta x over t squared ratio. Then what is going to be the answer for A? Your acceleration is actually going to be 2 times the slope of your x to t squared ratio. Now, once we look at our, like what we know that time and position. So then what we're going to try, we are going to try position and time square and try to graph this and then see if we can actually get a number that we want, or if we are going to get the graph that we are looking for, which is linear graph. Alright, so to be able to do so, what you're going to do, you can just copy the entire thing, copy, and then just have an Excel sheet and then spreadsheet, whatever you call it, and then you just copy and paste it. When you copy and paste it, you're going to see all of the numbers in one cell. You guys need to learn how to use technology, alright? So that's why I'm going to be basically going through all of the details, but you guys need to learn how to do so. And after this, how do I basically separate it? You can just try to type it, but that's going to take forever. But you have an option, data. If you click data, and then you go from split text to columns, then it is going to ask you an option like, how do you want me to split those texts? Then you're going to say, whenever you see a comma or semicolon or period or space. So what do we have in between two variables that I have? I have a space in between. So what is it going to do? It's basically whenever it sees a space, it's just going to move it to the next cell. So, but what do you have over here? Since there is a space in between time and like s in the parentheses, it basically separates this. And then you have the same thing in between like all of them, so it separates it all together. But you're going to just put them together first or once, and then you can just copy and paste it. But you're going to need to put them together first one time. Alright, now I had copied this one earlier. This is your second trial. So now, how do we get some data? Again, try to learn to use the technology so that it's going to make your life easier when you're actually dealing with this online stuff. So, we are going to look for the graph. Let's look at the graph of position and time, and let's see what kind of graph it is. So to be able to see the graph, make sure your first column is your x column, your second column is your y column. I'm not talking about x and y right here. X is being the horizontal axis, y is being the vertical axis. Once you have this selection, go to insert, and then you're going to insert chart, and once you do it, you can see it's going to sketch the graph for you precisely. And as you can see, this is the position time graph of the ball, right? So it is basically accelerating, but this is not a linear graph. But we weren't expecting a linear graph from position to time. But what do we expect a linear graph? Position to time square. So let's see how we can get actually position to time graph, or position to time square graph. So if you want, well, you're not going to need this, so you can just delete this. So how are you going to get the t-square values? Again, this is also a simple procedure. So you basically hit to an empty cell and then hit enter or equal sign. So once you start with an equal, that means you're going to write an equation. So what will be my equation? I am trying to find the square of the certain number. I'm trying to find the square of the time. So then how are you going to get the square? Basically, select the cell, and then you're going to multiply the same cell twice to get the square of the number, right? So once you hit enter, it is going to basically calculate it for you. And if you go to the down, like right bottom corner, hit, like click on it, hold on to it, and like bring it down, it is going to get the square of every number that you have in the order. Okay, and the way that it works, whatever you have in the cell as equation, it basically copies that equation in the down cell. And then it basically projects what you have, because this cell got the first information from this cell. So once you basically bring it down, it's going to come down here. And if you, let's say, you move it to the right side, so what is it going to do? It's going to go to the reference first, A3, A3. So this is the cell. And then you move to the right. So it's going to move to the right and get the square of that. All right, this is a little bit more Excel information, but you might need it later on. So this is now my t square, right? And then this is going to have the unit of s square. So now what do I need? I need position to x square, or time square. So this is, however, going to be my x-axis. So I'm going to keep it as the first, and then copy this guy next to it. And now I have horizontal values and then vertical values. Why do I have it this way? Because you see, delta x, oops, delta x is basically on the y-axis, and then t squared is on the x-axis. So that's why t squared is on the x, delta x or y is on the y-axis. Now I have my basically t squared to y numbers. Then what am I going to do? Insert, chart, boom. I have that linear relationship. All right. So now what do I have? What does this number give me, or what is this graph giving me? So graph alone doesn't tell me anything, but if you look at the slope of this ratio, position to time square, is basically giving me this section right here. All right. So I basically have, if I find the slope of delta x at t squared graph, then I have this information. Then to be able to find the acceleration, what do I need to do? I need to multiply this slope with 2 right here. So let's see what's my slope. And I know it's a little like too much information, too much technology if you've never done this before, but you guys need to learn those. These are going to be part of your life later on because you are Z generation, right? So now if you want to get the slope of this line, so what do? You can, like, there are a couple of ways, but I think the simple one is go to customize and then series, and then you're going to go to trend line, and then once you click on the trend line, you can basically, the type is linear, so you don't need to do anything with it. And then you are going to basically need labels and use equations. All right, now you basically have the equation right here. You see, your equation is negative 5.48 x plus 0.809. So what does that mean? Remember, the number in front of the x is your slope, and the additional extra, like the addition at the end, is your b. So b is your, I'm not sure if I can type on this. I can, let me take this to Word and then I can show you easier. Whoops. Actually, let's try this. Take this as a picture. Alright, give me a second, guys. technology, right? Alright, I think I have, I don't know why I don't have this. Here we go. So basically, once you look at this, you are going to see that this is the line equation, and the number in front of x, remember, y equals mx plus b, right? So m represents your slope, b is your y-intercept. So this number right here is 0.809, and this number right here is your slope. And what was the relationship in between? That got all messy right here. But the relationship was a equals 2 times slope. So my slope is basically negative 5.48, negative 5.48. So whenever I multiply this slope with 2, I basically get my acceleration. And once you multiply it, you're going to get something like 10.9. Since this is an experiment, this is acceptable, and it is negative, and the reason why it's basically going down. Alright, so I know it's a little bit too much of information, but actually once you know like how to do it, it's not taking forever. The explanation is taking a while, but once you know what's going on, it is not going to take too much of your time. And you have time until Monday, so you basically have 4 more days, so you don't need to worry about like how to do this. And if you still have questions, you can basically bother me, send me email, or like yeah, request a Zoom meeting. I'm going to be happy to help you. Alright, so let's see if anything else that I need to talk about. So your results, basically you're going to analyze the data the way that I show you. You're going to look at x to t square ratio, get the slope of this, and then multiply the slope with 2, and then find the acceleration. And or directly looking at this and getting a linear graph from position to time square, then you can definitely say that it is a linear, it's a constant acceleration, because the model tells us that acceleration is 2 times delta x over t squared. So if this is linear, then I have a constant acceleration. Alright, and I definitely have a linear graph of x to t squared, then that means the model of free-falling object is basically matching with a constant accelerating objects. Alright, so that is basically how you guys are going to analyze it. So I'm going to share this file with you, so you don't need to type anything for the data points, you just need to explain. So for this part, again, identify the type of object your group is dropping. So you're going to basically use the information or assume that you are doing the experiment in the video. Alright, but again, you need to state that you are using the information or the video that is shared with you in the data table. Alright, so you need to refer to this. Don't just say that we did it. Alright. Yeah, whatever, like all of the physics that I explained, you guys are going to explain it over here the way that you understood. Alright, I think that is it. I know it's long, but that's what physics, and that's how it looks like from distant learning. Alright guys, I hope it was helpful. And then again, if you still have questions, please reach me out.